Okay, today we're going to go over sine law. It looks as if there are two formulas, but these are the exact same formula. The only difference is they've inverted the fractions. Okay? So, in other words, you can choose to set the formula up the way we have it here with all of these sides, and we'll talk about this in a second, and angles on the bottom, or vice versa with the angles on the top and the sides on the bottom. Okay, so let's talk about what this actually means. This formula states that side A divided by sine of angle A, this ratio, this is a ratio, a number divided by a number, is equal to the ratio of side B divided by sine of angle B, which is also equal to the ratio of side C divided by sine of angle C. The reason these ratios work, okay, and this is very important because many of these triangles are going to have different names, and we're going to probably rename them for this, is that our angle and our side are always opposite. And we talked about this a little in our last chapter. Okay? So if I call this angle A, that means this side here is side A. If I call this angle B, that means this must be side B, the opposite. And if I call this angle C, this must be side C, the opposite side. It's very important you set the triangle up that way, otherwise this won't work. If you just randomly call this angle A and then this side A, these ratios won't work anymore. Okay? So in order for them to work, you need to set a triangle up where the angle, or the name of the angle, is opposite of the same named side. Now, the other reason that these are the same is to think of it as if it was a fraction. Okay? Let's say that this was 5 over 10. Okay? If I were to invert this fraction, so just to show you fraction rules here, if we have 5 over 10 is equal to 1 over half, is this true?
Yes.
Okay. If I invert them, so flip them both over, I get 10 over 5 is equal to 2 over 1. Is that true? Yeah. So in other words, this formula, all it is when we bring it down here is the inverted. It's the exact same thing. It'll stay the exact same because fractions, when they're equal to each other, can be flipped around and the ratio still stays the same. The reason we choose one or the other is because you're going to find, depending on what we're looking for, it's usually easiest to keep the unknown variable on top of the fraction. So, let's actually build a question here and go through setting up sine law first. Okay, so we've created example 1 here. They've given us this triangle here. Nothing indicates that it's a right angle triangle. Had it been a right angle triangle, we probably could have used our primary trig ratio, SOHCAHTOA, something like that. But sine law is going to work for triangles that are not right angle triangles. So, because we don't know that it's a right angle triangle, we can use it. Sine law will still work if it is a right angle triangle. The only reason we don't go to this right away if it's a right angle triangle, because it's a little more in-depth than solving SOHCAHTOA. Okay? So, like I said, the way we've seen our rules, they have A, B, and C. So I'm going to rename this triangle. It says TVU. It doesn't matter what I name it. I'm going to take away what they've called it, TVU, and I'm going to name it ABC. Wherever I put angle A, B, and C, it doesn't really matter. Call that angle A. Call this angle B, and this C. The only things that are very important are the sides in reference to them. Okay? So, if this is angle A, what is side A? 11.1. That's right. This has to be side A in order for this to work. This is angle B. What's side B? The unknown. Yeah, one of the unknowns. Good. The unknown side, which means by deduction, this must be side C. Okay? So again, in order to set this up, our sides must be opposite of our angle. Now that we have that, we're going to go into our actual ratio here. We'll write the rules. Sine A divided by side A is equal to sine B divided by side B, which is equal to sine C divided by side C. Now, in this triangle, there's a couple things I can solve for. I'm missing a side, and I'm also missing 2 angles. I'm going to solve the whole triangle. We're going to go through the process of finding every unknown side. In order to use sine law, we have to actually have a complete ratio, which means I have to have the measurement of an angle and its opposite side. Otherwise, sine law won't work, and we'll learn tomorrow what else we could use instead. But in order for this to work, we have to have a complete ratio. In other words, we must have one of these with all of the information inputted. So either the angle A and side A, angle B side B, or angle C side C. If I don't have a complete ratio, I can't use sine law. It won't work. We don't have enough information. So we're going to plug in the values we have here. Okay, you guys are going to help me out. Angle A is what measurement? Do we know it? It's unknown, so we're just going to call it A. What's side A? 11.1. Good. It's 11.1, so we put 11.1. Is equal to, what's angle B? Unknown. What's side B? Unknown. What's angle C? 31. And what's side C? All right. Do I have a complete ratio? Yes. Okay. That's very important. I do have a complete ratio. We have sine 31 and 5.8. That means we can use our sine law to solve this stuff. Now, here's the trick. There are technically 3 together, but I only need 2 of them. I just need to set one fraction equal to the other. Now, if you guys look at B, I don't have any bits of information here. So actually, I can't really solve anything in this. Okay? I'm going to work with first sine A, because I do have one piece of information. We have to have a complete ratio and 1/2 of the fraction, the other ratio, in order to solve. So in other words, this middle B is just going to drop off. We don't need it. We don't have information to solve it. It's not going to help us in this process. So we're going to drop that off, and we're just going to make these equivalent fractions. So I now have sine A divided by 11.1 is equal to sine 31 is equal to 5.8. Good. Now I'm actually solving for something. I have one unknown. That's angle A. We want to solve for angle A. In other words, I want to isolate it. So if I want to isolate angle A, because this is sine A divided by 11.1, I want to move the bottom part of this fraction to the other side. To do that, what do I need to do to move the 11.1 over?
Multiply.
That's right. We've got to multiply by 11.1 on this side, and it'll get rid of this guy. So then, we're left with sine A is equal to, we'll put this as a number because I know you guys work best with that. So that's not the calculator. There it is. Okay, so sine 31, we in degrees? Yeah, we are. Sine 31 times 11.1. All of this divided by 5.8, 0.985. Okay. Now the goal here, hope I typed that in the calculator right. Let's see. 0.985. The goal is to isolate angle A. Is A by itself right now?
No.
What's still attached to it? Yeah, you could say sine still attached to it. So just like in primary trig ratios, if I'm trying to find the angle, what do I have to bring to the other side? And what does it become on the other side? Good. It becomes the inverse. So then we have sine inverse. We have sine inverse, so negative 1, of 0.985. And that'll help us find angle A. So we're going to put that in our calculator. I still have that button. Perfect. Inverse of sine, 80.29. We're going to just round it at 80, okay? So this is approximately 80 degrees. So when we go back to this triangle, this angle here, A, is 80 degrees. Great. I got 80 degrees. How do I solve the rest of this triangle? I still don't know anything about B.
Minus 180 from 80 and 31.
That's right. We have 2 of the angles in this triangle, right? I have C, and I now have A. We know that a triangle, angles will always add up to 180 degrees. So what we're going to do to find out angle B is we're going to take 180 and subtract 80 and 31, okay? And that's going to give us 69 degrees, I think. Is that right? Good. So angle B is 69 degrees. Now that I have that, I have a piece of this ratio, sine B over side B. So like we said, because we've now discovered what the other angle is, I can set up my sine ratio again. So I'm going to set it up over here. We'll call it the next part of this question. Okay, make some room around. So, with our information, again, sine A divided by A is equal to sine B divided by side B, which is equal to sine C divided by side C. So, we have the A's. A is 80, and its side is 11.1, so we have sine 80 divide 11.1. So now that's a complete ratio, so we can possibly use that in our question. Or sine B, well, we have angle B, which we discovered to be 69. I still don't know side B. And then sine C, we had all that information. That was 31 and 5.8. So, if you guys look now in our sine, we actually have two complete ratios, which is great. This is a complete ratio, and this is a complete ratio. I can set either of them equal to this one to solve for B. Okay? Now, notice that the B is on the bottom. I'm going to give you a trick here. Instead of going through the longer algebra process, remember I told you we could essentially flip these. It's always easiest to work with an unknown variable when it's on the top of a fraction. So it'll actually be easier if we invert all of these and put the B on top. It'll be simpler for us to solve. I'm also going to show you that it doesn't matter which of the ratios we set it equal to, we'll still get the same answer. So I'm going to solve this two ways. Okay? So take note, I am going to invert it when I rewrite it at the bottom. So the one on the left will set equal to side A, which was sine 80 divided by 11. Whoopsie, I said I was going to invert it and I didn't. Let's invert it, okay? We're going to invert this. So now I'm going to put 11.1 on top divided by sine 80, which is equal to side B on top, which is equal to sine 69. That's one set of ratios, so we'll say that was the one we've done in red here. Or in blue, I'm going to set these two equal to each other and invert them also, again, so that the variable's on top. 5.8. Now, you don't have to use both ways when you guys go about it. I just want to prove to you that it really didn't matter which ratio we set it equal to. B is equal to sine 69. Okay? In both instances, we're solving for B, and that's pretty easy for us, because all we need to do is move what it's divided by to the other side. So in this case, I need to move sine 69 over here and multiply. And same thing over here, sine 69, and I just need to multiply by. So it will now read sine 69 times 11.1, everything divided by sine 80. No, this won't be an inverse because we're not looking for an angle. Okay? It's only when we're looking for the angle that we use that sine inverse. And this will be roughly the same thing, sine 69, just with the other ratio, times 5.8 divided by sine 31 equals B. Anyone want to help me out? What B is equal to there? Try it in your calculator. I'll also try it here.
10.5.
10.5? Which one did you use, the left or the right?
Left.
Left? Okay. Somebody try it with the right and tell me what you find. I'll try it with you. So 69 sine times 5.8 equals, I'll divide it by bracket 31 sine and bracket 10.5. So whether we found the left or the right, we set either ratio, we got the exact same answer in this question. Okay, so it doesn't matter how we set it up. Now that looks like quite a bit of work, but this can be simplified with a little bit of practice.